Hello, my name is Mohammad Amir Zarpan Afad, and I'm studying environmental engineering at University of Calgary.
My name is Kevin Gori, and I am a student of University of Calgary, and I am studying at in chemical and petroleum engineering.
Hello, myself, Animej Zamgade. I'm currently studying electrical and computer engineering at University of Calgary.
Hi, my name is Jawad Anis, and currently I'm studying at Master of Engineering in Electrical and Computer Engineering at University of Calgary.
This is the second video presentation about Deepwater Horizon oil spill. Next, please. Next, please. Well, if I want to give you a quick summary about the oil spill, it occurred on April 20th, 2010 on BP's Deepwater Horizon oil spill drilling rig in a Gulf of Mexico at a Macondo well, and it was due to the failed cement seal and the blowout preventer that did not respond. The consequences were 4.9 million barrels of oil over 87 days, which was released into the ocean, around 65 billion in damage, 11 deaths, and 17 injuries, which all of these led to stricter offshore drilling regulations. Next one, please. Well, if I want to talk about cognitive and personal biases, there are like three important categories. The first one is a overconfidence bias. In this category, managers and engineers overestimate their control over the drilling technology, and they believe that because of the previous successful operations, everything is okay, but clearly it wasn't, and all of these resulted in ignoring abnormal pressure test results, and they didn't even think about a chance of a blowout in the oil rig. The second one is the confirmation bias. Decision makers and managers focused on the information that was aligned with their beliefs rather than the safety of the well. Warning data showing pressure abnormalities were dismissed, or they reinterpreted it as it was a good result. The last one is the normalization of deviance. Repeated small safety violations became normal practice over time, and they got used to it. And workers accepted the risky shortcuts as standards which reduced their sensitivity to danger. Next one, please. And the impact of biases on engineering ethics. The first one is ethical blindness. These biases clouded their judgment and suppressed their moral responsibility, and they begin to prioritize cost and schedule over safety and environmental duty. For the groupthink, there was a high pressure on them to agree with the management, and this discouraged the workers and engineers to, well, generally speak up. And open communication, which is a key in these kind of projects, broke down completely. For hindsight and accountability, after the disaster, the investigation was conducted, and that reveals that this wasn't just a technical issues, and systemic ethical failure was involved. These biases prevented engineering from acting aligned with the fundamental of engineering ethics, which is, well, basically safety of the public and environment. Next one, please.
Yeah, for the technical and risk failure, this disaster began with poor engineering and risky decision. This blowout preventer failed to because of weak design and maintenance. BP also chose the cheaper, riskier, well designed and ignore abnormal pressure readings. These shortcuts taken to save time, money, and directly cause to the blowout. Next, please. For the communication and organization issues, there was no clear leadership between BP Transocean and Halliburton. Managers focused on the cost and deadline, not safety. Warning signs were dismissed as a false alarm. Safety cultures was replaced by the production pressure. Poor communication made the system weak and unsafe. Next, please. For the oversight gaps, government oversight was also fault. The Minerals Management Service held conflict of interest and did not inspect properly. Emergencies plan was unclear, showing the total lack of parameters. And the last one is the lesson. The strong regulation, transparency, and ethical leadership are essential to prevent such disasters. Next, please.
Let's not talk about engineering and technical lessons. The disaster revealed critical weakness in safety and decision making and risk management. Cement barrier testing and pressure monitoring were inadequate and not inadequately verified. The blood preventer failed due to poor maintenance and due to redundancy. Lessons: engineering reliability must always outweigh cost or pressure, schedule pressures. Organizational and communication lessons: the company miscommunicated among PP, Transocean, and Hubbalton that contributed to misinterpreted data and unsafe decisions. Fragmented leaderships blurred responsibility for the safety and decision making. Also, the production targets overshadowed the safety culture, creating complacency. Lessons learned from this were clear communication and shared accountability are essential in complex engineering projects. Regulatory and ethical lessons. Weak regulatory oversights and conflicting roles of the US management service allowed unsafe practices. Lack of transparent reporting, delayed response, and accountability. Engineers failed to uphold their ethical duty to prioritize public safety and environmental welfare. Lessons learned are strong. Independent regulations and ethical integrity are vital for public trust. And let's now talk about cultural and professional lessons. Safety must be embedded in company's culture, not treated as a checklist. Also, the company should empower engineers to speak up about safety practices without fear of retaliations. Ethical leaderships and transparency should also guide all operational decisions. The uh, lessons learned from this is future engineers must build a culture where ethics, accountability, and safety come before profit.
So let's talk about prevent something like Deepwater Horizon from happening again. We need a real shift in culture where safety is not just a box where you have to tick, but something everyone lives by. First, we need a stronger safety culture. Every worker should have the power to stop unsafe work without worrying about being blamed or being dismissed. Second, engineering oversight should be tighter. All critical designs and procedures should be reviewed independently and safety system checked regularly. And not but the least, transparency matters. Companies need to clearly document how safety decisions are made, and people should feel comfortable speaking up when something doesn't seem right. We also need a smarter system and stronger accountability to prevent this kind of disaster from happening again. Next slide, please. So the accountability risk management has to move beyond checklist using real-time monitoring, predictive analysis, and worst-case planning can help catch issues before they turn into disasters. Companies should also be helped. Companies should also be held responsible. Safety performance, not profit. Not only profit, but also the safety performance should influence how leaders are rewarded. And finally, we must keep learning. Every major accident teaches us something. As future engineers, it's our duty to carry those lessons forward and make ethics a part of everything we design or decide. Next slide. And that's all the reference that we used in our slide and the project. That's everything.
Thank you.
Thank you.